Welcome to Brain Vision.
A sealed metal container containing gas at 20 degrees Celsius and a sealed metal container contains a gas at 20 degrees Celsius and 1 atmosphere. To what temperature must the gas be heated for the pressure to double to 2 atmospheres? Right, so we're going to start off from the ideal gas law. So for a particular gas in certain conditions, we have P1 V1 is equal to N1 RT1. And for a second situation, we would have P2 V2 is equal to N2 RT2. And we're going to call this equation 1, and this is equation 2. Now, if we now divide equation 1 by equation 2, we have P1 over P2 dot V1 over V2 is equal to N1 over N2. R divides by R, T1, so dot T1 over T2. And we observe in this question that it is a sealed metal container, so the volume is constant and the number of moles is constant. So we have P1 over P2 is equal to T1 over T2. We know that P1 is equal to, we have P1 is equal to 1, P2 is equal to 2, and T1 is equal to 273 plus 20, so 293 Kelvin. These are obviously both ATM, but it doesn't really matter because we're just interested in the ratio between P1 and P2. It could be bananas and it would be the same answer as long as we are constant with our units for pressure here. And T2 is our unknown. So setting this T2 as the subject of the equation, we have T2 is equal to T1 dot P2 divided by P1. P2 over P1 is just 2. So T2 is equal to 2T1. 2 times, not T2 there, is equal to 2T1. So 2 times 293 is 586, so is equal to 586 Kelvin, which in degrees is equal to 300. So subtracting 273 to get back to degrees from Kelvin is 313 degrees.